This is a tooth dataset, and we will see how to get surface area. Now, to get say volume, we just press space bar and then give get volume to give the volume. Similarly, we can also give get surface area, and with surface area we have three options in selecting the neighborhood for the surface voxel selection. You can have a 26 neighborhood or a 18 neighborhood or a 6 neighborhood, so basically face, edge and diagonal as well. So so the boundary when selecting 6 neighborhood option will be much thinner compared to the 26 neighborhood option. So let's start with 6 and we will see the difference. So 6 neighborhood voxel, 6 neighborhoods for the surface voxel selection. We also have an option of saving these boundary voxels into as a volume. So let's check that if you want to, and then it will ask us for the file, and then this is the surface area. So these are the voxels that are non-zero and contribute to the surface area calculation. So that's your final surface area. Now let us see this file here, which saves the boundary voxels. So I've given input here, and then I will drag and drop the t.pvl.nc.001 as a raw file. The grid size will be same as the original volume, and this is so all the voxels that contribute to the surface area calculation are saved as value 128, and everything else is saved as 0. So these are the boundary voxels that were used for surface area calculation using this transfer function. Now let us save, get the surface area, now this time with 18 neighborhood. Let's again save it, say T18, and as you can see the surface area, the number of voxels that contribute to the surface area has grown because your surface is a bit thicker, and we will see that here. So I'm dragging t18.pvl.nc.001, which is a raw file, and then now you can see that this border is a bit thicker compared to 16. Now let us save, get the surface area for using 26 neighborhood. Again let us save the boundary voxels, say T26 and you can see that the size, the number of voxels is now larger because your boundary is thicker. So again Drishti input, and let's drag and drop the t26.pvl.nc.001, and you can see that the boundary is a bit thicker. And we can also see that in if we load Drishti and then drag and drop, let's start with T6. So this is the the boundary. And let's load T26, and this is the boundary for T26. Now this is the connectivity, 6 connectivity and 26 connectivity. So 6 connectivity is, now if this is the voxel under consideration, then we consider only these 6 neighbors in order to in order to decide whether this voxel here is surface voxel or not. So what I do is I check these 6 voxels, and if any of these voxels have opacity 0, so any of these 0, 1, 2, 3, 4 and 5, any of these 6 voxels has opacity 0, then I consider this voxel as a surface voxel. Now in case of 26 connectivity, I consider all these voxels surrounding, immediate neighbors surrounding this voxel under consideration, and then if any of these voxels has 0 opacity, then I treat this voxel, the central voxel, as a surface voxel. Now in case of 18 connectivity, we take all these 6 voxels here plus these 4 voxels as well as these voxels here. So basically those that are connected diagonally to this central voxel are not considered. So 8 voxels that are diagonally connected to the central voxel are not considered, and that's how we get 18 connectivity. So this is the logic I have used when calculating the surface area. Basically count all the voxels that are surface voxels, and the way I decide surface voxel is based on the connectivity, whether it is 6 or 8 or 18 or 26 connectivity. If that voxel, if a given voxel is deemed as surface voxel, then count it towards the surface area calculation. And user can also save the voxels that have been used to calculate the surface area as a volume.